Ladies and gentlemen, welcome. This is again our seminar 4ST601 Statistics in English. Today we will continue with seminar number 7, our 7th seminar. We will start with a large example about the seasonal component and the regression approach to seasonal component. We will use a seasonal time series. We will start talking about the decomposition of the time series, yes, because we will decompose the time series to trend and seasonality. Yes, we will speak about this. We will model this time series, and at the end we will try to calculate according to appropriate model, yes, with trend and seasonality, with trend component and seasonal component. We will try to calculate the prediction, the forecast, yes. In our example, first example which I prepared for you, we have the real-time series about the development of average gross monthly wages. Yeah? So make ready these formulas in front of you. Yes, it's page 3 and the bottom part, because we will use these formulas. Yes. And we can open our data sheet in Microsoft Excel, where you can find this example. Use the data about the development of average gross monthly wages in the Czech Republic. We have a quarterly published data. Maybe Mr. Hellman said to you that in quarterly and monthly published data, yes, it's possible to observe seasonality. Yes, if we have annual published data, there is no seasonality. Yes, but in quarterly or monthly, we can observe the seasonality. So we will check the sheet 2 in this Microsoft Excel. Using additive decomposition, we will try to estimate or calculate appropriate regression model. Yes, we will fit the trend and seasonality. On the basis of our regression model, we will calculate the prediction, forecast, yes, of average gross monthly wage in the Czech Republic on observation from first quarter of year 2013 to fourth quarter of year 2013. This means 4 observations. It will be good to check the sheet 2, so I will open this sheet for you. You can see that we are starting with first quarter of year 1995, as we can continue with second quarter of year 1995, etc. So each year has 4 observations, yes. First quarter, second quarter, third quarter, and fourth quarter. And after, we are continuing with new year, yes, year 1996, first quarter, 1996, second quarter, etc. So this is quarterly time series, yes, this values. Values are in Czech crowns. It's a historical time series, so it was real. Yes, it was real that in year 1995 was average gross monthly wage in Czech Republic 7,000 Czech crowns. Yes, it's in nominal prices without recalculation to current level, price level. Yes, so it's a real data set. Okay, so you can check that we have 72, I think, yes, there is 73 row, yes. The last observation is fourth quarter of year 2012, yes, 2012. Fourth quarter. This is the last observation, and because we have a label in first row, so we know that we have 72 observations. Yeah, so 72 observations, long time series, quarterly. What can we do? We will check the formulas one more time, and I will show to you the principle of the decomposition. What is the most important for us now? Mr. Hellman wrote for you that the time series y in time t. Yes, the time series in time t, we know that t is from 1 to capital T, for example, in our situation, from first observation to 72nd observation. Yes? This is our length of the time series. So this time series can be decomposed to TR trend in time t plus seasonality is denoted like S. Yes, seasonality in time t plus, and there is some E in time t, some error term. Yes, error term of this model. And in this course, yes, of 4ST601, I can show to you only the approach, the regression approach with linear trend. What is it, linear trend? Linear trend TR in time t is a classical linear function, as probably I cannot see it now, b0 plus b1 t. Yes, I will check it from the formulas. Yes, b0 plus b1 in time t. Okay, so this is the trend. Yes, trend, linear trend. So either decreasing, yes, trend, or increasing trend. Yes, some long-term tendation, long-term development of the time series. Yes, we know that it's possible to have a parabolical trend, yes, or exponential trend, etc. But in this course, I can show to you only the linear trend. Yes, in this approach. Seasonality, yes, you have written that seasonality can be modeled using the dummy variables, yes, using dummy variables. Mr. Hellman using seasonal differences and dummy variables x, yes, seasonal difference 1x1, yes, plus seasonal difference 2x2 plus seasonal difference 3x3 plus seasonal difference 4. I will delete this, yes, x4. I will check the formulas. Okay, seasonal differences, yes. So we can express the seasonality like this. So it's necessary to create some dummy variables, x1, x2, x3, and x4, for example in Excel, and we can explain these dummy variables. Dummy variable, for example, x1 is variable which can be equal either to 1 or 0. So you can imagine this variable like a binary variable. Yes? So x1 is equal to 1 in the situation that we have first quarter of the particular year, yes, and is equal to 0 in the case that we have any other quarter. Yes? So we can write in all other cases. Yes. So this is a situation for first dummy variable x1. Yes. So there is a model for seasonality, yes, seasonal difference times dummy variable x1, and x1 can be equal to 1, so it's switched on, yes, or 0 is switched off, yes. And we can continue with this, with variable x2. x2 is equal to 1 in the case that we have a second quarter of the particular year, and variable x2 is equal to 0, and I will write only the shortcut, yes, in all, I'm sorry, all other cases, yes, in all other cases. So this is the situation of x2, and we can continue with x3. x3 is equal to 1 in the case that we have a third quarter of the particular year, yes, and x3 is equal to 0. I will try to write it correctly, in all other cases, yes. So this is the third situation, and fourth situation, x4 is equal to 1 in the case that we have a fourth quarter of the particular year, and x4 is equal to 0, and one more time correctly, in all other cases, yes. So this is the structure of dummy variables. I will delete this model now, yes, and now you can imagine the structure in Microsoft Excel, the combination of these variables, yes. We have here observed variable y in time t, and there we have a values, yes, values of average wages, yes. We need, if you remember, the model TR, yes, trend. Trend will be modeled like B0 plus B1 T. So we need to have, yes, another variable, the time variable T, which will be here, variable T. And because we have a linear trend only, yes, it's enough to use values 1, 2, 3, 4 until 72. Yes, the value 72 will be the last position, the last number, the last value in this time variable, yes, which will be added to the model. Yes, so this is all right. And now our seasonality, yes, this structure. So dummy variable x1, dummy variable x2, dummy variable x3, and I will write here x4. And now you can imagine the structure, the combination of these variables, yes? Binary combination 1 0 0 0 1 0 0 0, yes, to the end. And you can continue 0 1 0 0 0 1 0 0, etc. Yes, because it's a dummy variable x2, yes, and x2 is equal to 2 in the situation that we have a second quarter. Yes, we have here first observation, first quarter, second quarter, yes, third quarter, fourth quarter, etc. Yes, so this is the structure. x3, the binary combination for x3, autumn, yes, this is spring, summer, autumn. So 0 0 1 0 0 0 1 0, etc. and here 0 0 0 1 0 0 0 1 to the end. Yes. Okay, maybe Mr. Hellman talked about the problem about the issue of perfect linear correlation, perfect linear dependence in this structure of regressors, and because there is possible to find a perfect correlation structure between these variables, it's necessary to omit one dummy variable, and this model with trend and seasonality is solved like one equation with one unknown. Yes, one equation with one unknown variable. So we have a deal, yes, it's our deal. It's possible to omit any from these dummy variables, and according to your formulas, I can see that we have a deal that omitted is winter. Yes, the winter is omitted, will not be put to the model. Yes, so this is the winter. Bye bye. Okay, so we will create this structure to Microsoft Excel. Yes, and after we will continue. Yes, so easy, we can continue. Okay, so we are back in Microsoft Excel. If you remember on the table, yes, I had written some structure, observation, average wage. Yes, so it's a development of empirical values of our time series. So what we need to adhere time variable t, and after 3 dummy variables. Our deal is that we will use spring, summer and autumn. Yes? The winter will be omitted. So please, you can start here. We will create t, x1, x1 will be here, x2 will be here, and x3 will be here. Yes, so I will use alignment. Okay, so time variable t. Yes, what is it? 1, 2, 3, 4, etc. So the simple linear development of time variable t. Yes, in our situation, it's just a number of observation from first to 72nd. Yes, so you can create this line, yes, to the end. You can see that our last value, our last observation is 72. Yes. Okay, so this is easy. And now the binary structure. So please return back here, and we will write here 1, 0, 0, 0, 1, 0, 0, 0, yes, etc. So it's possible to copy this, yes, copy and paste to the end. I will do this at the end. Yes, so there will be 0, 1, 0, 0, and here in the case of third column, 0, 0, 1, 0, yes, and x4 is omitted. So here 0, 0, 1, 0, yes. Now I have here this field, copy, yes, paste, and please paste it to the end. Yes, it's necessary to copy these values until the end, so until the last observation. Where is the end? The end is here. Yes, you can see the last observation, 4th quarter of year 2012. Average gross monthly wage 27,170, 72nd observation. Yes, and this is the last structure. Yes, column D, E, and F is my dummy variable x1, x2, x3. Okay, so we are almost ready. If you remember, we need to use a special add-in for calculation of sophisticated regression models. It's possible to do this manually, yes? I know the formulas, how estimate the parameters, but you don't know, yes? You don't have formulas and it will be very, very complicated. It will spend 45 minutes, yes? A long time. So we will check if we have on the data leaf, data analysis, no. Yes, it's empty. So we must click on File button, and here on the bottom we have options. Yes, there you have options. So please click on options. You will see another window and find add-ins. So options, and we have here add-ins. Yes, here on the left side. And on the bottom, manage Excel add-ins, and there is Go button with 3 dots. Yes. And it's necessary to select Analysis Toolpath, and on the top right corner, yes, on the data leaf, you will see Data Analysis. So please select Analysis Toolpath. Here you can see Data Analysis. So I will scroll up. Maybe it will be good for you to rename this on Y in time t. Yes, Y in time t, this is t, and here we have 3 dummy variables. So now we will select data analysis, and we must select the field with dependent variable and independent variables. Dependent variable is average wage, and independent variables are the time, yes, t, and your 3 dummy variables. Nothing more, yes, nothing more. So we can do it like this. There we have a data analysis. Wait a second, you will see this table, and it's necessary to find here regression. Yeah, so please find regression, okay, and as I already said, input Y range, yes, is your average wage, and input X range is time, X1, X2, X3. Today I will also select the labels, yeah, so think on this, yes, I will select the labels. Input Y range with label is here, yes, from the first cell to 73rd, yes, 73rd cell, yes. Input X range is time, X1, X2, X3, and you can see that I am selecting everything down, yes. Okay, so can you see it's selected everything here, also with labels, yes, with labels. So I will return back, and I must select the labels, yes, and that's all, yes, it's selected. I will click on OK. The least squares method will calculate the coefficients, yes, of this model. So please do this, and there will be new sheet, yes, with results. So we will check these results, and after we will continue, yes. So okay, please check if you can see the same values like me. I will zoom these tables, and I will use only, I don't know, for example, 2 decimals, yes. Okay, so this will be the most important for us, and this I can delete. This will not be necessary ever. So can you see these coefficients? As there is calculated intercept, the coefficient for intercept, coefficient for time variable t, and 3 coefficients for w variable x1, x2, x3. Okay, so this is the output, yes? We must check the formulas, yes? Because in formulas, you will see that we estimated, we calculated this model. Trend and seasonality, yes? Plus some error term, error component, yes? We have calculated B0 and B1, yes? So intercept and the slope. And after we calculated A1, A2, A3, yes? So our coefficients, yes, for variable x1, x2, x3. We must calculate A with stripe, A mean, A with stripe, yes? Like summation A1, A2, A3 divided by 4. This is very important. It's a summation of 3 values, but it's not calculated like divided by 3, but 4. Yes, it's very important. And after, if we have A with stripe, we can calculate the seasonal differences. Seasonal differences for the particular quarter. This is recalculation of 3 coefficients on 4 coefficients, because we solved one equation with one unknown, yes? One equation with one unknown variable. So we must recalculate 3 values to 4 values, yes? J is the particular quarter. In our situation, first, second and third is calculated in the same way, yes? Like calculated original coefficient minus my calculated mean, yes? So this is the same for spring, summer and autumn. But winter was omitted. So the winter must be calculated in different way. Winter, seasonal difference for winter is calculated simply like minus A with stripe, yes? And finally, it's necessary to recalculate B0. So we must recalculate 3 alphas, 3 A's, yes, to 4 alphas or A's, yes, and we must recalculate the coefficient for intercept B0. From B0, it's necessary to get B0 with star, yes? And that's all, because after we have B0 with star, B1 is the same, and we have calculated 4 seasonal differences. From 3 values, 4 values, yes? So, I will do this in Microsoft Excel so easily, yes? We can open Excel, and this is calculation of A1, yes? Maybe I will zoom this table. So x1 is A1, x2 is A2, yes, according to our formulas, and x3 is A3. So one more time I will change this letter. Okay, yes, so this we calculated. Intercept is B0 and this T is B1. So I will write it as well, yes. So intercept, this is B0, but just B0, yes, B0 without star, B0. And this is B1. Yes. Until now, it's everything alright. Yes. Okay. B0, B1, A1, A2, A3. So the first step, calculate A with stripe, A mean. Yes, so for example here we will calculate A mean. Yes, A mean, A with stripe. Do you remember the formula? It's a summation. It's a summation of these three values divided by 4. Yes, so do this. This value plus this value plus this value, close the parenthesis, divided by 4. Yes, this is very important to calculate correct value of this A with stripe, A mean. Okay, so this is calculated here, and now, what now? 4 seasonal differences, yes, but 3 differences for spring, summer and autumn will be calculated in the same way, and the winter will be calculated in different way. Yes, so where I will calculate this, for example here, yes, SD1, SD2, SD3, SD4, yes. So here we will calculate these differences. And one more time, yes, because I think that you already forgot this. So original A calculated in regression analysis minus A with stripe. This will be for spring, summer and autumn. And for the winter it will be just minus A with stripe, yes. So we will do this. Please calculate here equal sign. Maybe I will use bold yellow color. Okay, equal sign. Original A minus A mean. As you can see, it's very easy. It's very easy if you have Excel, because there is minus something. Minus something, yes, it's difficult, but Excel knows, yes, so please calculate it here, enter, and here, equal sign, original A2 minus A mean, yes, enter, equal sign, original A3 minus A mean, yes. And this is the last difference. The winter is calculated like minus 1230. So the result will be 1230 with positive sign. Yes? So enter, and there is equal sign minus this value, enter. Yes, you can see everything is alright. So A mean and the seasonal differences, and probably the last important thing which is necessary for you is what? B0 with star. Yes, B0 with star. So here B0 and the star. Yes. Will be calculated. Where is the formula? Here, like original B0 plus A with stripe, yes, plus A mean. So we'll do this. Okay, so here equal sign, original B0, original B0, 9,048 Czech crowns, yes, plus this value, plus this value, enter, and I will use bold and yellow color. Okay, and now in this Microsoft Excel sheet we have everything necessary for us, and we will use these calculated statistics in our sheet 2, where we have the data with the development of every year's monthly wages. Okay, so we are back in this sheet where we have empirical data and prepared the structure with our variables, and we know that seasonal difference, or in general seasonality, seasonality repeats every year, repeats every year around the trend, almost in the same way. This is the definition of deterministic seasonality about which talked Mr. Hellman. So seasonality is repeated, repeated fluctuations which are almost in the same way, equal every year, repeating of fluctuations around the trend. So it will be good to create here another column with seasonal difference J, because we have 1, 2, 3, 4 seasonal differences which are repeated in the same way every year, because of changing of particular quarters. So from our calculation here, we have seasonal differences here. It's necessary to select these 4 values, use copy and paste special, because I must delete the formulas. I must delete the formulas from this calculation. So please use Ctrl and C. Ctrl and C, and it's copied. Now I will click on another sheet where we have this prepared column, and there is paste, and I must use paste values. Can you see paste values and the first button? So without formulas, paste values. Click here, and now it's necessary to copy, Ctrl C, copy, Ctrl C these values and paste to the end, repeated values. Data will be repeated. So copy and paste, and you can see that if I have a first quarter, there is a difference, seasonal difference, minus 854 Czech crowns, and I have here again first quarter, in year 1996, and there is a decreasing, by 854 Czech crowns. So the differences, seasonal differences, are repeated, are deterministically repeated to the end. There is the end. You can check last 4 observations: first quarter, second quarter, third quarter, fourth quarter. I will use 2 decimals in all cases. It will be enough for us. It's not necessary to use 3 or more decimal positions. Okay, so there we have differences, and now we can fit the trend. Trend TR in time T. Okay, so TR in time T. In your formulas and the PDF file, you can find in your formulas that trend is fitted, is calculated like B0 plus B1 in time T, but not only B0, but B0 with star. So we will fit the trend. Okay, we can return here, and the trend will be calculated. Equal sign, We must click on the sheet where we have the regression output. So please do this. Can you see equal sign? Click on the sheet one time only, yes? On the sheet where you have these coefficients and select B0 with star, yes? I only clicked on this value, yes? And now I will use function 4. Please use function 4 button because we must lock this cell. So now please click function 4, F4, and you will see in the command log the dollars, yes? And now plus B1, where is B1? Here. So write only, yes, on your calculator, plus, and click here on B1, yes? So plus B1, and B1 must be also fixed, yes? Because it will be the same during all calculations. So again, please press F4, function 4, and you will see dollars, yes? So again, function 4, and now please press star like multiplication, yes, star like multiplication, and now we will return back to the sheet where we have empirical data and our created time variable t. Yes? So please click on the sheet where we have the data and select this time variable t. And that's all. This will be variable. Don't use function 4 here. So you can see from the sheet where I have calculations, yes, I selected fixed B0 star, plus I selected B1, yes, again fixed, and only this t is variable. Okay, so that's all. Enter, and there is fitted trend. Yes, you can copy these formulas to the end. It's possible to show to you the proof that I have here correctly fitted trend. I think that yes. So I will show to you proof that this is the real fitted trend. Yes. The trend development. Okay, so I will select this column, yes, and I will use insert. There we have charts, and I will use line chart, yes. So this will be line chart. I will use right button, move chart to new sheet, and I will write here trend. Yes, okay. So I will increase the font. I will use bold, and there is from first observation to 72nd observation. Yes. So this is our trend function. Yes. Can you see this trend function? Maybe I will use right button, format data series, and size. I will increase the size. Okay, and now it's better. You can see increasing trend, and around this trend fluctuates seasonality. Yes. What is its seasonality? We have calculated seasonal differences, yes, SD, SD1, SD2, SD3, SD4, seasonal differences, seasonal changing, yes, which is repeated every year almost in the same way because of changing of quarters, yes. So you can check the development of seasonal differences. Can you see this column? You can select, yes, this column, and you can create a chart. Yes? So please do this if you want. You can select this column, yes, and we can insert line chart, yes, and again we can click on the right button, move chart, yes, new sheet. This is seasonality, yes, seasonality, okay. And I will use higher font, bold, yes, and maybe it will be good to format data series and higher size, 4 points. It will be enough. So this is seasonality. Can you see the changing? The deterministic changing, the deterministic fluctuation. Deterministic fluctuation around trend. This is the seasonality. So what we must do now, because we would like to fit the data, so we'll calculate a summation of trend and seasonality. Why? Because it's written in formulas and it's logical. Please check it, yes? Formulas. And we wanted to model YT. And YT is calculated like summation of trend and the seasonality. We have fitted trend, yes? B0 star and B1T. We have fitted seasonality. SD1x1, SD2x2, SD3x3, SD4s4. So we will calculate the summation and we will see fitted data. So please do this. We will calculate here on the top of this page y in time t fitted. Yes, y in time t fitted. And it will be very easy. We will calculate summation of trend and seasonality. Yes, so please do this. Trend in time t plus seasonality, seasonal difference in time t. Okay, and you can copy the formulas to the end. Yes, and we can see what is fitted here, because I can show you the chart, yes? Please, if you want, you can select this time series, also with the label. You can click on Insert button and use line chart, yes? I will use right button, move chart, move to new sheet, fitted data, okay, and I will use home button, I will increase the font, I will use bold, and I will use format data series, and I will increase the size of this line. Okay, so there you can see fitted data. Yes, fitted data. It will be good to compare fitted data with empirical data. Yes. So I will add here to this chart also the development of empirical data. So I will rename this plot as fitted data, and I will write here empirical versus fitted data. Yes, empirical versus fitted data. Yes, and we have here fitted. So I will use the development of our empirical time series. Where is our empirical time series? Here. This column B. So please select everything. What is in column B, where we have y in time t, our empirical time series. We will copy these values and we will paste these values to this chart. Yes. So please, you can do this. You can select everything what is here. Yes, select everything. Now you can use Ctrl and C, copy. Yes, and copy, and there is empirical versus fitted. I will click, yes, on the data area. I clicked to data area and paste. Control V, yes, please do this. And you will see the comparison. You will see the comparison. The blue curve, yes, is fitted model, the development of fitted data. The blue fitted, yes. The blue is the fitted, and the orange is empirical. It will be good to have the legend, yes. So maybe I will use format. Design. Add chart element, and where is the legend? Legend, for example, top. Yes. So if you want, there is design. Yes. No format, but design of the chart. Yes. And on the left side of this screen, add chart element. And I edit legend. So you can see y in time t is empirical development, and y t fitted is the fitted development. Okay, so we have fitted model, yes, we have fitted data, and there was also written on the basis of this regression model, calculate prediction forecast of average gross monthly wage in the Czech Republic on observation from first quarter of year 2013 to fourth quarter of year 2013. So 4 values, 4 forecasted values, yes? So we will do this in our calculation sheet. Okay, so I'm back here in this sheet, and I will scroll down, yes. So here I will move to the left, and our duty is to calculate value on this position 2013 first quarter, 2013 second quarter, 2013 third quarter, and 2013 fourth quarter. Yes, these values are unknown. Yes, we don't know these values, but we are able to calculate the forecast. Yes, and the forecast will be here. Why? Because then we have a fitted data, and we are able to extrapolate, yes, the data. So maybe it will be good to fix this first line where is view. I can freeze panes, yes, and now you can see that we are able to see this first line with labels, yes? Okay, so this is unknown for us, but we know that we are calculate observation on the 73rd, 74th, 75th and 76th position, yes? This is known for us, yes? Because there is the development 70, 71, 72, yes, and we must continue. Position, observation, 73rd, 74, etc. Yes, it's logical, because we need to calculate these 4 values. Values on this observation. Okay, so it's possible to copy this binary system, yes, okay, so I can add here this binary system, copy and paste, yes, okay. There, seasonal differences. What we said about the seasonal differences. Seasonal differences are repeated almost in the same way, in our situation, in the same way every year because of changing of particular quarters. Yes? So the data will be repeated. So again, in the same way, data will be repeated. So we can copy these values. Yes, we can copy these values, seasonal differences, copy and paste. Yes, and we have here seasonality. Yes, trend. Can you see this line? Do you know how to extrapolate this trend? Yes, we will extend this line. Yes, we will extend this line by a simple mathematical function, which is already written in Microsoft Excel. You can see this simple function, this one. Can you see this simple function? B0 with star, yes, plus B1 times time. And you know that if we use another time, 73 observations, 74, 75, 76, we are able to extrapolate the trend, yes? So we will copy these formulas because you can see we already have here created the time variable t. So do this, yes? We can copy these formulas. So there is our extrapolated trend. And if we calculate the summation of extrapolated trend and extrapolated seasonality, what is the extrapolation of seasonality? If you check this seasonality chart, yes, you can imagine that we adhere another series of changing, yes? So we extrapolated these values and you can calculate here a summation trend plus seasonality, and you have here the forecast, yes? So the forecasted average gross monthly wage for the first quarter of year 2013 is 25,555 Czech crowns. Yes, the forecast on the fourth quarter, yes, fourth quarter of year 2013 is 28,404 Czech crowns. Yes, average gross monthly wage. Why is the wage highest in the fourth quarter almost every year or practically every year? Because of Christmas and special bonuses, yes, from your employer. So Christmas and special bonuses. So this is the end. I hope that it was clear. It was a very large example, but very complex. And remember this, yes, you can see that it's very useful to know how to model trend and seasonality in the time series. Maybe if I see you later in some advanced classes, advanced courses, I am able to show to you more complicated procedures for model seasonality. Okay, so almost 1 hour of solving a very, very complicated example. This was beginning of our 7th seminar, and now we will continue with something, according to me, yes, less complicated. You will see very easy examples, but with different statistical method and different part of statistic. We'll start with probability, theory of probability and theory of random variables. Don't be scared, yes, it will be alright, because I will show to you only the basic calculations and basic principles of the theory of probability. I have in Czech language at this university, Prague University of Economics and Business, also the subject introduced to the theory of probability. And in this course we are solving probability 13 weeks, 13 seminars, yes? So you will see only really a small piece, yes, very small piece from this part of statistics. And we will start with these formulas and with some simple examples. If you open my Excel sheet, there is first example about this theory 7.2. We will start only with basic definitions, etc. So we have a classical fair dice, a cube with 6 sides. Yes, and we will calculate some probabilities. So we have here A, B, C, D, E, F, G. We have here G questions, yes, or duties. So we will solve this on the whiteboard. At the beginning, we must define, yes, the probability of random event A. Yes, probability of random event can be calculated like a ratio m divided by n, because in denominator there is what I want, what I require. Yes, so I can write it here. What I want. Yes. What I want or what I expect, yes, what I require, and in the denominator we have all options, yes, all options, all possible options, yes. So this is the classical definition, and we must also define, yes, define the random event A. Yes, in our situation, because we have here example about a fair dice. Yes, so you can imagine classical fair dice. So this will be a dice. There is the position, the side with position value 6. So we will define this random event A that I will see number 6 of this dice. Yes, so I will see number 6 on this dice. Yes. Okay, so I will see number 6 on this dice. This is our random event, and according to our example, in one row there falls number 6 on this dice. So in one row, so we have only one row. So probability that random event A, yes, will be, I will see number 6 on this dice 1 times. Yes. We can calculate this like a ratio 1 divided by 6, because on this dice we have 6 sides exactly, and I require only this one side. Yes, it's absolutely the same probability if you want to calculate probability that you will see number 4, for example, on this dice. Yes, so 1 divided by 6 can be calculated on calculator. You will see, if you calculate this ratio 1 divided by 6, the result is 0.1666 periodical. So this is the final result, because probability is a value, yes, from range 0 and 1. But for interpretation, it's possible to multiply this by 100 and interpret in percent, yes? So it's possible to say that the probability that you will see within one roll, yes, the value 6 on this dice is 16.67%, yes? It's possible to interpret the probability in percentage. Yeah, so this is the first case. What else? In one roll, there falls an even number on this dice, an even, yes? So we have odd and even numbers. Odd is 1, 3 and 5, and even 2, 4 and 6. Yes, so according to this situation, you can see that M, what is M? What I want. Yes, here I wanted only one side. Now I want one from 3 sides. Yes, so M is equal to 3, and now everything still is the same. Definition, I will see an even number on this dice, yes? I will see an even number on this dice, yes? Okay, I will write here 3 dots and I will calculate probability of random event A. Yes, it's calculated like this ratio, m divided by n. In our situation, 3 divided by 6. This is 0.5. This is the final result, and you know that it's possible to interpret this like 50% probability. 50% that you will see even a number, and also you can expect that we have a 50% probability that we will see odd number, yes? It's 50-50 on this dice. During 2 rolls, there falls number 6 exactly 2 times. So we must define, yes, another random event. So it will be good to delete everything from this whiteboard, because we will define random event A and random event B. So definition A and definition B. I will see number 6, yes? I will see number 6 in the first attempt, yes? And the definition of B, I will see number 6 in the second attempt, yes? So there will be written in the first roll, for example, yes? Attempt, roll, etc. So in the first roll, and there will be in the second. And this function is AND. And logical function AND, yes, is a multiplication, the star. So it will be necessary to calculate probability that you will see random event A and probability that you will see random event B. In your formulas, you have written this probability of A and probability of B. This is the same, yes? And the same operator, logical AND, multiplication, or this. Okay, so we can calculate it. We have a fair dice. Yes, we will roll and we will check what we can see. So I will be happy if I will see 1 divided by 6, number 6 in the first roll, yes, and 1 divided by 6, I will see number 6 in the second roll. Equal sign, you can use calculator, 1 divided by 6 times 1 divided by 6, it's 1 divided by 36, and you can calculate this ratio. Result is 0.02 0 to 7, 7, 7 periodical. Yes. So this is the probability, and you know that it's possible to calculate multiplication by 100 and interpret this result in percentage. So 2.78%. Yeah, so this is possible, and this is the response of C. Yes, so we calculate the probability that during two rolls, yes, there falls number 6 exactly 2 times. Yes, exactly 2 times. Okay, we can move to another duty. During 2 rolls, there will not fall number 6 2 times. There will not fall. So I will not see. I will not see, and this not will be placed here and here. Yes, I will not see number 6 in the first row. Yes, and in the case of second row. Yes, so we must learn negation. Yes, the function non. This will be very important. Negation or function non. Yes, there is written not. In logical technique, we are using non or negation. So I will delete this. I will delete this, and we will repair this. Yes, I will not see number 6. So I'm calculating probability of random event A non. Yes, because there is a negation. I will see number 6. So now I will not see. So either we can negate the original definition A, or we just simply write here this negation, and also here this negation. So I require value position 1, 2, 3, 4, 5 without 6. So what is required? 5 divided by 6, and what is required in the case of second row? 5 divided by 6. Yes, so result is 25 divided by 36. You can calculate this ratio, 25 divided by 36, 0.69444 periodical. Yes, and this is possible to interpret in percentage like 69.44 periodical percent. Yes, so this is the probability that you will not see position 6 in the first row, and you will not see value 6 in the case of second row. During 2 rolls, yes, we will see number 6, the position 6, exactly once. Yeah? So we have 2 rolls, but we would like to see the position 6 on this dice exactly once, only once. Yes. So I have here the definition of event A and definition of event B. I will see number 6 in the case of first row, and the definition of random event B. I will see number 6 in the case of second row. So I will be happy if I see random event A. I will see number 6 in the first row, and I will see random event B non. What is a non? I will not see value 6 in the case of second row. So this is one option, yes. Or I will be happy if I will see position 6 in the case of first roll, and I will be happy if I will see value 6 in the case of second roll, so random event B. You can see we have here probability where is A and B none, or A none and B. This is either and this is or. Yes, so this is classical OR function. Yes, which can be calculated like classical summation. This is AND function, this is AND function, and this is calculated like classical multiplication. So now it's very easy because we can calculate this random event probability that you will see random event A. I will see value 6 in the first row, 1 divided by 6, and I will not see value 6 in the second row, so times 5 divided by 6 plus OR function A known, 5 divided by 6, and 1 divided by 6. That's all, it's very easy. So I will solve this. 1 divided by 6 times 5 divided by 6 plus 5 divided by 6 times 1 divided by 6. Enter. So result is 5 divided by 18, and this is equal 0.2777 periodical, and this is possible to interpret in percent like 27.78%. Yeah, so this is the result, and this is the probability that during two rolls there falls number 6 exactly once, exactly 1 times. Okay, the last two duties which we must calculate during two rolls, there falls number 6 at least once, yes, and the last duty during two rolls, there falls an even number at least once, yes. I will start with the last one, yes. What is it? An even number, even. So 2, 4, and 6, yes. And we have two rolls. During two rolls, there falls an even number at least once. So either in the first case, or in the second case, or in both cases together. Both cases together. So we have random, we have a definition of random event A and random event B. Yes, and you can imagine the definition of random event A is during first roll we will see an even number. Definition of B. During second roll we will see an even number. Yes, and at least once. It means either in the first case, or in the second case, or in all cases together. Yes? So it's not possible to write only probability of A or probability of B. Yes? I will rewrite this to statistical form. Probability of A or probability of B. This is not enough, because if I draw for you the space of these events, event A and event B, I can draw it like this. This is a space of random event A, yes, and this is the space of random event B. So you can see there is a field of A, there is a field of B, and there is something what is common, yes, something what is common for both events together. Yes. Imagine that we will calculate only this probability of A and the probability plus, yes, probability of B, like 3 divided by 6 plus 3 divided by 6. Yes. It will be a fail, yes, because we are calculating even number during 2 rows. Therefore, an even number at least once, either in the first attempt, or in the case of second attempt, or in both attempts together. Yes, and the result of this will be 6 divided by 6. 6 divided by 6, it will be 1. This can be interpreted like 100%. And where are odd numbers? Yes, 1, 3, and 5. Yes, there is no place for odd numbers, and this is the wrong. This is wrong. So I must calculate minus this place. What is the same for these two events together? So the correct calculation of this is probability of A plus probability of B minus probability A and B together. Yes, so minus this one position in the middle. Yes, so I will write it like this, A and B, and there will be written minus probability A and B. Yes, this is the same. Okay, so please, we can calculate this. Probability of A, 3 divided by 6 plus 3 divided by 6 minus multiplication 3 divided by 6 times 3 divided by 6. Yes, so we can calculate the result 3 divided by 6 plus 3 divided by 6 minus multiplication 3 divided by 6 times 3 divided by 6. Result 3/4. 3/4 are equal to 0.75. And this can be presented like 75%. 75% is this probability. So we calculated the last duty, yes, the last task during 2 rows. Therefore, an even number at least once. So an even number either in the first attempt or in the case of second attempt, or in both cases together. And the correct calculation is according to this formula. Yes? And now we can do this with the value 6 during 2 rows. Therefore, number 6 at least once. So either in the first case or in the second case, or in both cases together. Yes, so do you remember the probabilities for value position 6? 1 divided by 6 plus 1 divided by 6 minus multiplication 1 divided by 6 and 1 divided by 6. Okay, so I will delete this. And I will calculate the result here. 1 divided by 6 plus 1 divided by 6 minus multiplication 1 divided by 6 times 1 divided by 6. Enter 11 divided by 36. This can be rewritten like 0.03055 periodical, and this in percentage is 30.56%. Yes, so this is the final probability. Remember this chart, yes, it's quite good for understanding this situation. We will continue with another example and also the last example for today. The basket contains 30 cards, 20 red and 10 blue. Yes? So 30 cards are divided to red cards and blue cards. By random selection without return, we will withdraw 2 cards. So I will withdraw 1 card, yes. And I will withdraw another card, yes, without returning to the basket. And we have here 2 questions. What is the probability that 1 card will be red and the other one will be blue, yes? And how will the probability change if we make a selection with return? So it will be good to define, yes, define 2 random events, yes, and the definition of these 2 random events depends on you, yes, or me, for example. Why? It's possible to define more events, yes, in different way, and according to this definition, yes, create the calculation. So, for example, yes, here I will define definition, yes, definition of random event A, and here there will be definition of event B, yes, and there will be the sentence. So, for example, first selected card from the basket is blue. For example, yes, I created this event. So, the first selected card from the basket is blue. Okay, and the definition of random event B. The second selected card from the basket is blue, for example, yes? This is my definition. I created this event A and B. So, the second selected card from the basket is blue. You can train at home, you can create as the definition of A. For example, the first selected is red, the second selected is red, or you can create a combination, yes? And after, you can train to calculate the result, and you will see that you will have the same result like me. Do you believe me? I hope that you believe me. So I will show to you how to solve this, yes, on the whiteboard. Okay, so what was written in case of A, our duty A? What is the probability that 1 card will be red and other will be blue? So there is the basket, yes, with 30 cards, and I know that 20 cards, yes, have a red color and 10 cards are blue, yes, and I select 1 card and another card without returning. We have definition of A and definition of B, and A and B is almost the same. The first and the second selected card from the basket will be blue. This was my definition. And I would like to calculate probability that 1 card will be red and other one will be blue. So I will calculate, I will be happy if I will see random event A known. What is it A known? Because A, the first card selected from the basket is blue, negation is red. The first card selected from the basket is red. This is A known. and I will be happy if I see random event B. The second card selected from the basket is blue, yes? So this is one option. Or I will be happy if I will see random event A. What is it? Random event A. The first card selected from the basket is blue. And another one must be red. So, and I will be happy if I will see random event B none. What is it B none? B is that the second card will be blue, and none, the second card will be red. So either this combination or this combination. So this can be written like probability either A none and B, or A and B none. Yes, we already seen this formula before. So now I can write here the probabilities. So it's very important to know that I defined random event A and B like the first card is blue, so the second card is blue, yes? So this is my definition which I created, yes? So A none, the first is red. We have here 20, yes, 20 red cards divided by 30, because in the basket we have 30 cards. And multiplication, random event B, the card, second card is blue, so 10 divided. But now I already have one card in hand. Yes, the basket has no 30 cards, but only 29. This is very important, yes? And different situation, so or, yes, plus, this is either or. I will check the card, yes, definition of A, the first selected card is blue, yes, 10 divided by 30, the basket was full, yes, and B none is, the second one is red. Yes, I have here 20 red cards, but I know that the basket, yes, is one card less, yes, so 29. Okay, and this is the solution, yes, so we can calculate this, we can solve this. 20 divided by 30 and 10 divided by 29 plus 10 divided by 30 times 20 divided by 29. The result is 40 divided by 87. This can be calculated like a relative number 0.45977, which can be interpreted in percent like 45.98%. So this is the probability that you will select two cards without return, and one card will be red and the other one will be blue. Yes, so this was the selection without returning. And now, very fastly, I will show to you the difference between the selection without returning and with returning. Yes, so everything is the same. We have definition of A and definition of B in the first attempt, and in the second attempt we will see the blue card. Yes, everything is the same, but the basket is still full. So if I select something as divided by 30, I will check the color, yes, and I will return this ticket back to the basket, yes. So and 10 divided by 30. The denominator is still the same, yes, in comparison with this. Plus 10 divided by 30 and 20 divided by 30 again. Yes, you have still full basket because you will select the ticket. Yes, you will check the color and you will return this ticket back to the basket, shake it, yes, and you will select another one. So the basket is still full with 30 observations, with 30 tickets. So multiplication has bigger priority than summation, and I can write it here. 20 divided by 30 times 10 divided by 30 plus 10 divided by 30 and 20 divided by 30. Result is 0.4444 periodical. Yes, we can interpret this in percentage like 44.44 periodical percent. Yes. So you can see that in comparison with selection without returning, yes, so this is without returning, this is with returning. So in comparison with this, the probability is a little bit lower. Yes, a little bit lower. So please remember the difference between selection with and without returning. Okay, so that's all from today. This is the end of our 7th seminar. Next week in 8th seminar we will continue with theory of probability, and we will start with random variable, discrete and continuous version. So that's absolutely everything from me today. I wish you the nice rest of the day. I hope that I will see you next week, and bye bye.